In this MongoDB with Python tutorial, I'll be continuing from where I left off in video 1 and showing you some advanced MongoDB features. Specifically, I will discuss schema validation, bulk inserting, data modeling, advanced queries, and introduce you to a great module called PyMongo Era. If you've not yet watched the first video in this series, please do so by clicking the link in the description or the card in the top right of your screen. Now, I will mention that MongoDB is the sponsor of this video, and their team has helped me come up with this fully guided tutorial for all of you. Lastly, if you haven't already claimed your $25 in free MongoDB Atlas credits, you can do so by clicking the link in the description and using code MKTTIM. Without further ado, let's get into the video and learn about some more advanced features of MongoDB. Alright, so I'm here in Visual Studio Code. I have my MongoDB extension installed. Highly recommend you install that if you don't have it. And I have some code here that we wrote in the previous video that just connects me to my MongoDB cluster. Now, the database I'm going to use here is production. And again, if you haven't watched that previous video, please go back and watch that. It's going to give you some fundamentals and kind of a basis for what I'm going to explain here. Now, for this video, I need some kind of example and some data to work with. So the example I want to create is something where we have books. So those will be stored in one collection. And then we have authors. Those will be stored in another collection. And then we'll have a reference between the book and the author, so we know which authors wrote which book. And this way we can have one author writing multiple books without replicating that data. And I'll talk about why we actually made that kind of design decision as we start creating this. However, the first thing I want to do here is talk to you about something known as schema validation and how that works in MongoDB. So let me open up the documentation. I will reference quite a bit of documentation here as we go through this video. I'll leave it in the description and you can feel free to read through and get some more details if you'd like. All right, so we have schema validation. Now, essentially what this is a way of creating some type of structure in your MongoDB database. So typically when you insert a document into a collection, there's nothing that enforces it has to have a specific field. And when you create a new collection, you don't have to specify what columns you're going to have, what's required, what the type of everything is. You literally just create the collection and it allows you to insert any type of document that you want. The documents you insert could be completely different. That's one of the great benefits of MongoDB. However, sometimes you want to use MongoDB and you also want to have some type of enforcement on the data that's being inserted in a collection, and this is where schema validation comes in. So what this allows you to do is, similarly to a SQL database, set up some predefined columns, or in this case fields, and require those whenever you insert a new document. So when we're talking about our book, for example, we may require that you have a title, you have an author, you have a published date. All of these fields must be on the document to insert it. Otherwise, it won't actually let you insert that. So you can read through this documentation if you'd like to see exactly how this works. But you can see here that when you create a collection, you have the option to actually pass a validator. And this validator allows you to specify the schema here of the collection. So we can have things like different properties. So the properties would really be the required fields here. We have a name, year, major, GPA, address, etc. So we specify all of the different types here by using bson type. We specify our descriptions. There's all kinds of other stuff that we can do. And yeah, we set up our schema validation. So let's actually do this here in MongoDB. I'm going to just copy in a validator because I don't need to write all of this out. It's not really that helpful for the video here. So this is one. We have a book validator. So we start with a JSON schema. We say the bson type of the schema, right, is going to be an object. And then we have our required. Now, for required, these are going to be the fields that we need to pass or that we need to have on our documents. And for properties, these are all of the fields and their corresponding types. So I have my title, it's type string, it has a description. We have our authors, this is going to be a type array. And since it's an array, we need to specify the type of the items. So I'm saying the items in this array are going to be of type object ID. So this is going to reference an object from the author collection. We then have our description. We then have a published date, type date. We have type, and this is a field which is of value enum, which means we can either have fiction or nonfiction as the two allowable values here. And then we have copies, minimum value of 0, the type is int, and then we have our description. If you want to write a more advanced schema validator, again, reference that documentation there. Of course, I can't go through everything you can possibly do. And if you want the BSON types, you can find those again from the documentation. But anything that you would think is a type is probably one, and you can likely guess what the types are. Of course, that you can check from the documentation. Okay, so now that we have our validator though, how do we actually use this? Well, the first thing we need to do is create a collection called book. And then once we've created that collection, we can actually modify it and kind of add this validator to it. So what I'm going to do here is say DB, and actually it's not going to be DB, it's going to be production because that's the name of my database. And then I will create a new collection. And I can do that using the create collection function like this. I also could just write dot and whatever the name of the collection is, but I would need to insert something in there then for that to be created. So this way I can just specify what I want to call this. So I will call this a book. And I'm just going to put this in a try except block just to ensure that if I run this code multiple times, I don't get an error where I try to create a collection that already exists. So I'm going to say accept exception as E, print E. Okay, so now that I've done that, I can actually modify this collection using the following command. I can say production, and that's not what it is. It's going to be dot and command like that. And then I can pass a MongoDB command. This command is going to be call mod like that. I'm then going to pass the collection that I want to modify, which is going to be book. And I'm going to pass a validator equal to the book validator, and that's going to add that. And then when we insert documents, our schema will be enforced. So let's actually just try running this code right now and see if this works. So let's run and let's see what we get. And we get an error. So let me have a look here what this error is, and I will be right back. All right, so as you saw, we were getting this error here. It's saying user is not allowed to do action. Actually, good error to run into. I can show you how we can fix this. So there's kind of 2 steps to do this. We need to go to MongoDB Atlas here, which I already have open. We need to click on database access once we're in our project. And then we need to go to our user. We need to change its permission so it has access to the admin permissions. So what we do that is we click on edit. We go here to database user privileges, select on built-in role, and then change this to be Atlas admin. So to perform the command that we're trying to perform, you need to be an admin user. Makes sense. So we need to do this. Now we also could create a new user. We can, set up custom roles, all kinds of stuff we can do in here. For now, though, that's all we need to do for our current user. Okay, so I've changed that for our user. Now that we've done that, there's only one more step, and it involves this connection string right here. We just need to make sure that when we're authenticating as an admin. This doesn't happen by default. So we need to add the following line here at the end, or the following, query parameter. We're going to put an ampersand because we have an additional parameter here. And then we're going to say auth source is equal to admin. Again, that's going to sign us in as the admin and give us access to this command that we're trying to use. So let's now save and rerun this. Let's clear the screen, and hopefully this will work for us this time. And this is collection book already exists. Okay, so that means I've already created the collection. That's fine. However, the production command here should actually be working, right? We should now have modified. This wasn't giving us an error, and that is all good. Now, if we want to verify that this is indeed working, let's go to MongoDB Compass. Let me go to refresh here. We should have a production database, which we do. And if I go inside of here, you can see that I have my book database. Awesome. We can go to validation, and when we go to validation, we can see that we have these JSON schema here, or the schema validation actually set, and we can change the action as well as the level here for validating the schema. Okay, so that is good for now. We've created our book collection. However, now that we've done that, we want to create our author collection as well. So I'm going to put this inside of a function here. I'm going to say define, and this is going to be create book underscore collection. And we'll indent all of this just so we don't repeat this code multiple times. And now we can make a new function. I'm going to say this is going to be create the author collection. And then after we do this, we'll insert some sample data. So for now, let's copy our author validator. I'm going to put it right here. Okay, so we have our JSON schema, BSON type, same thing as before. I won't go through this again. And now that we've done that, we want to create the author collection and then add this schema to it. So we're going to say try, and this is going to be not DB, but this will be production dot create collection. We're going to create author. We'll say accept exception as E, print E, and then we'll run that same command that we did before. So this is going to be production dot command call mod author, and then the author underscore validator like that. Okay, so I think that's the exact same as this. Just want to make sure everything looks good. Looks good to me. So now we can call this function. So create the author collection. And let's run this, and hopefully everything will work fine. I don't get any errors, no output. That is good. If we want to verify that this is working, we can go back here to Atlas, and now we see that we have author. And if we go to validation, we can see that we have this. Now, I guess we could have a look at schema as well, or there's nothing in here, so we can't really see anything right now. Okay, so that is all good to me. We have author, we have book. Now that we've done that, we need to add some sample data. So let me stop this function call. Let's create a new function here. Let's say create underscore data. And in here, we need to add a bunch of books, and then we need to add a bunch of authors. Or I guess we're going to add our authors first, actually, and then our books, because our books rely on the authors, right? So let's do this. I'm just going to copy in some sample data here that I have for authors. And now I can show you how we perform a bulk insert. Now, I believe that we saw this in the last video, but it's important to mention again, because this is a more efficient way to insert data rather than individually insert every single one of these entries. So let me slow down for a second here and really go through what we're about to do. First of all, we have this DT. Now, that is actually imported from datetime, so I need to import that at the top here. I'm going to say from datetime, import datetime as DT, just so I can get a datetime object very easily. Okay, so now we have that. So that's what we're doing with our dates and time. We then have our first name, last name, and date of birth. And if we go back here to our author schema, we notice those are the only 3 required fields. So it's fine for us to insert those. But what I'm doing again is I'm going to insert all of my authors. Once the authors are inserted, I'm going to grab the IDs of these authors, and I am then going to use them to create my books, because the books rely on what authors are, well, writing them. And we're going to use, again, this reference type relationship as opposed to the embedded documents. And I'll talk about that more in a second. For now, though, let's insert this data. So what we can do is say, I guess we'll go the author underscore collection is equal to, and this will be production and dot author. And then we already know how to do the bulk insert, but it's going to be author collection dot insert underscore many. And we can just pass a list here of the authors that we want to insert. Then what I'm going to do, though, is get all of the IDs of this these insert authors. So I'm going to say inserted underscore IDs is equal to this. And then this is going to be dot inserted IDs. And actually, let's just call this author underscore IDs like that. Actually, we can just call it authors for now. That's fine. Even though this is called authors, we'll just override it. So now we'll store a list of all of the inserted IDs of all of these elements. Okay, so that's how you do the bulk insert. Again, much more efficient than individually inserting. So make sure if you are inserting a lot of stuff, you use insert many as opposed to insert one. Okay, now that we have done that, we need to create the sample data for our books, again, that relied on the author. So let me copy in this. Okay, so this is our books. Let's make sure the indentation looks good. And what I'm doing is just accessing the indices of the insert IDs from my authors for what author wrote what book, right? So for here, I have one MongoDB Advanced Tutorial. This one we're going to say is written by me. So I'm grabbing author 0, which is going to be the ID of this inserted document. So that's what I'm doing here. I'm putting this inside of an array or a list because I could have multiple authors. I then have the publish date. I'm just saying, well, that's today. So datetime.today. Type nonfiction, copies 5. And all of these here have the fields that are specified in our schema validation. Okay, hopefully that makes a bit of sense. Not super important. Those are just what our books are. And now we need to insert our books. So to do this, we're going to say the book underscore collection is equal to, and then this will be production dot book. Okay. Then we need to insert all of these. I don't really care about the IDs this time, so I can simply say book collection and not dot update, but dot insert underscore many. And I'm just going to insert my books like that. Okay, so that's it for creating our sample data, and that gave you a little bit of taste of the bulk insert. And now what I can do is say create data like that. I think that's what I called the function. And when I run this, everything should be good. So let's run the code. Notice here that I don't get any errors. And if I go back to MongoDB Atlas, I give a little bit of a refresh here. We can see that we have our different books and we have an array of authors, which are referencing object IDs of the authors from the author collection. Okay, so now that we've done this, let's take a quick pause. let's talk about data modeling in MongoDB and why I made the decision here to actually put the authors in a separate collection, because there's arguments to be made for embedding them versus having a separate collection. So I'm here again on the MongoDB documentation. I'm just looking at data modeling examples and patterns, and I want to quickly go through how you kind of make a decision on if you prefer to have embedded documents or references, because that can be difficult to figure out and that can have a large impact on performance. So typically speaking, when you have a one-to-one relationship, that means maybe I have, say, in this example, one address for one person, it's totally fine to store that address as an embedded document inside of the person. Now that makes sense because typically when you're retrieving the person, you're going to be retrieving the address, only one address per person, or maybe multiple addresses per person, but they're specific to that person. It makes sense to store it inside. However, if you were to have one address that was associated with, say, 5 people, 6 people, or one object for that matter that multiple people are going to have a relationship with, so you have kind of a one-to-many or many-to-many type relationship, then what you usually want to do is take that document, so let's just use address for this example here, store it in a separate collection, and then make a reference to that address from all of the different documents that reference it. So all of the people that share an address, they would have a reference to that address. Now, the reason why you may prefer to do this is because it's going to take less space. It's going to take less space because now you don't need to duplicate it on multiple people. It's in a separate collection. And it also means when you make a modification to this address, since it will be stored in a separate collection, so like this, anyone referencing it will automatically have that update made or that modification made. Whereas if you were storing this address and you had it embedded in 4, 5, 6 different documents, you would need to change it in every single one of those documents to make sure you have consistent data. So those are two of the main things you kind of want to keep in mind. Is the document that I'm embedding going to be referenced by multiple different documents, or is it only referenced by one? If it's only referenced by one, totally fine, go ahead and embed it. If it's referenced by multiple, you still can make an argument to embed it, but you definitely want to consider the two things that I just talked about before. So hopefully this is giving you a little bit of a sense of why this can be a difficult decision. But now I want to talk about something here called the subset pattern. So oftentimes when you're retrieving a document, there's other documents, either embedded or referenced, that you want to have a look at. Now, it can be very time consuming and slow down your server if you're grabbing, say, every single reference for a specific document every time you grab it, or every single embedded document for a document every time you retrieve that document. So this example here, they have a bunch of movies, and it can be very time consuming to grab every single piece of detail about all of these movies every time. So the subset pattern here is saying, well, what you should do is store a subset of the information that is important and that you're frequently retrieving in a document, as opposed to storing all of it and store the additional data somewhere else, which can be retrieved when you need it. That's essentially the premise. You can read through here and see exactly how they would implement that. But the idea is that if you store kind of a slimmer version of a document, it's much faster to retrieve. You can get all of the data that you need very quickly. And if you do require the additional data, then you can always grab that and ask for it, as opposed to always grabbing every single piece of data, which again can be slow and time consuming. So, I mean, if we read through this here, it says here, currently the movie collection contains several fields that the application does not need to show a simple overview of the movie, such as full plot, rating information, etc. So instead of storing all of the movie data in a single collection, you can split the collection into 2 collections. You have movie and movie details, and then you only grab the movie details when you actually need that, right? So that's kind of the subset pattern, and what's this talking about here. Now, there is some trade-offs on using the subset pattern. This can require multiple calls, right, or multiple kind of query operations. It can require you to do some type of join operations, which I'll show you how to do later on. And it's something you just need to consider when you're kind of making this design decision. Now, this was more on one-to-one relationships, okay? So when you have one document referencing another document in some way. However, now we have one-to-many relationships. So in a one-to-many relationship, you're going to have one document that references many different possible things, right? Now, in this case, we have the embedded document pattern, we have the subset pattern, and we also should have here the reference pattern. All right, so here on this page, we're looking at modeling one-to-many relationships with embedded documents. Now, this is going to be similar to what I talked about before, but I just want to quickly read this to you here. It says, embedding connected data in a single document can reduce the number of read operations required to obtain data. In general, you should structure your schema so the application receives all of its required information in a single read operation. So that is for efficiency purposes, and this is kind of stating why you would use this embedded document pattern, where when you have, again, say multiple addresses, as I've talked about, you store them in an array here of addresses. This is totally fine. It's going to make it very quick to retrieve the addresses. However, again, if you were sharing these addresses with other people, it might make sense to put them in a separate collection because of the reasons I stated. Now, though, we also have the subset pattern, so same thing can happen here as with before. When you have a ton of nested documents, that leads to a large document in general that you need to retrieve, because that's to retrieve all of the embedded or nested ones. And sometimes it can be common to just store a subset of, in this case, say, reviews, as opposed to every single review, and then grab all of the reviews when you require them. So I won't go through this. We already kind of talked about this before. This is just more specific here to a one-to-many relationship. Okay, let's move on to the next one. Again, you can read all of this from the description. So continuing here, I'm looking at model one-to-many relationships with document references. Now, this is a great example of, again, why we want a reference. When we have a publisher and we're treating this as an embedded document, this publisher likely is going to publish multiple books, and that means that I'm going to have this publisher embedded in multiple documents, and I'm going to continue to repeat it and duplicate it when I really don't need to do that. So rather than doing it like this, we're going to create a reference. Now, they've done it in the opposite way that I did in our example, but they've made a reference here of books, and books is essentially an array that has all of the IDs of the books that this publisher has published. Now, we did it the other way, where we had an ID on our book that pointed to the authors, or we had IDs because it was an array. Either way, it's fine. But again, this avoids this kind of duplication that we had before and makes it easier for us to say modify the founded date or the location or add a field to our publisher without having to do it in a ton of different places. So that's really all to show you here. That's kind of an introduction to data modeling. Of course, as your database grows larger, there's more design decisions that you have to make, but this gives you kind of the core, I guess, choices that you have. You can use embedded documents, you can use the subset pattern, you can use a reference, and that's what you're going to be using in MongoDB. You have to make your decision and kind of lay out your arguments on which one you would prefer to use based on the type of program you have and how you're retrieving information. With that said, though, let's go back now and actually start writing some advanced queries in MongoDB and use some of this sample data that we created. All right, so for a majority of the rest of this video, what I'm going to do is just write some advanced queries and demonstrate how we perform kind of multiple operations and do just a lot more advanced stuff that we haven't yet seen. Now, what you can do if you're really kind of a beginner and you don't want to write these super advanced queries is you can always just grab all of the documents from a collection, for example, and then you can use Python to parse through them. So you can, look at the fields manually, write your Python code. Now, that's not the optimal way. That's not going to be very efficient, and you're going to be retrieving a ton of data that you don't need, which obviously is not ideal. But I just want to mention that there is times where maybe it's way too challenging or difficult for you to come up with the query on your own using kind of the MongoDB language. If that's the case, write as good of a query as you can, and then use Python to kind of parse and modify the results as you see fit. Anyways, though, I will show you some advanced queries. Of course, there's a ton more. Everything will be available from the links in the description and the documentation. However, what I want to do now is I want to retrieve all of the books that contain the letter A. So kind of a random thing, but something you may want to do, especially if you were, say, searching for something or you had a search string that needed to return some books. And I'm going to show you how we use regular expressions here. So I'm going to just write a variable called books containing, and then this is going to be A, and this is going to be our production.book.find. And for the query here, we need to put the field that we want to do the query on. So this is going to be title, because I want to see if A is contained in the title. And then I'm going to use this operator here called $, and then regex, so standing for regular expression. Now, for the regular expression, I can just use A, and then inside of curly braces, just put a 1. And this specifies that we're looking for something that contains at least one A. Okay, so now that I've done that, I can just print this out. So I can say printer. Actually, I don't know if I have that defined, but we'll look at that in a second. .pprint, and I can print the list of books containing A. Now let me just come up here. So I need to import pprint, which I have. And I'm just going to create my pretty printer here. So printer is equal to, and then this will be pprint.prettyprinter. So now I can use that to get a nicely formatted output. Okay, so let's run this here and see if we get what we're looking for. And when I do this, notice I get a list containing books that have the letter A in the title. So of course we have advanced here. And we have the Grey Gatsby. Of course, we have an A. We have another A here. Great. So there we go. That was the first query. Now, these operators that I'm going to use, there's an entire list in the documentation. I'll go through a bunch of them, but quickly, let's bring up a list of some different operators just so that we can have a look at some that we can use. Okay, so I've just clicked into operators here from the side, and we have some options. So we have aggregation, update, and then query and projection. Right now, we can look at query and projection where we have like equals, greater than or equal to, in, less than. We have logical operators, element operators, evaluation operators, geospatial, array, bitwise, projection, all kinds of different ones. And then we can even continue down here, right, and go to like update operators where we have ones like current date, increment, min, max. I just want to show you this so you know that there is a lot more, and anything you want to do, you can likely do by using these type of operators. Okay, back to this though. Let's write another query. The next query is going to be a join operation, where what I want to do is essentially grab every single one of my authors, but I want to have a field on my authors that contains all of the books that they wrote. So how do we actually join these two collections together and get our data kind of aggregated? So this is going to be authors and books is equal to, and this will be production.authors, not .find, but .aggregate. And what .aggregate allows us to do is essentially pass a pipeline of different operations that we want to perform in sequence. So what you can do is perform one operation that will give you a result, and then the next operation you perform will be performed on that result. So you can kind of chain or aggregate multiple operations together, and that allows you to get more advanced queries and write some more advanced stuff. However, aggregate also allows you to use specific operators that can only be used in the aggregation. So that's why we have to use this here. So in this case, what I want to do is use lookup. Now I'll go to the documentation and show you what this does. So let's go here. All right, so I've just pulled up lookup here. Just took me a second to find this, but it says the definition is performs a left outer join to an unsharded collection in the same database to filter in documents from the join collection for processing. So obviously a bit of a mouthful here, but essentially this allows us to join two tables together. The left outer join is exactly what we want. So we'll grab every single element from the original collection, which will be author, and then any matches if there is matches. Okay, so let's have a look at how we use lookup. So in lookup, we start with from, not form, but from. This is going to be the collection that we want to look up in, or that we want to perform the join with. So this is going to be book. We'll do book because, this needs to be author because we're doing author here. If we had book here, then we would have done author here, okay? After the from, we need to have our local field. And this is going to contain kind of the ID or what we want to match with the foreign field from our author collection. So the local field is the field on author that we're going to look at to perform the join. So this is going to be _ID. And then the foreign field is not going to be ID, but this is going to be authors, right? Now, MongoDB will automatically handle the array for us, so we don't need to worry about that. But again, for the foreign field, we go with authors because on the book collection, the authors field is what contains the IDs of the authors, and then ID is, the ID of the author that we're looking for in the foreign field. Hopefully that makes a bit more sense. Can't really explain it more than that. And then lastly, we have as, which is going to be the name of the field that's added to our author documents here that are returned that contains all of the books. So that's actually all we need to perform the join. So let's just print this out. I'll just copy this line here. We can comment those out for now. We no longer need that. And this will be authors and books. Okay. And let's run the code here and see the result that we get. Let me clear the screen. And notice that I get all of my authors. So I have the ID of my authors, and then I have books. And this contains embedded documents of all of the books. And that's what our aggregation operation did. So we have this book, another book that Tim wrote, date of birth, first name, last name, etc. Continuing, we have the next books, date of birth, first name, last name. You get the idea. There you go. That is how you perform a join operation in MongoDB. using lookup. Actually fairly straightforward. And again, MongoDB handles the array for us. So if there was multiple authors, then it would give this field on all of the authors that wrote a specific book. Okay, let's comment that out. And let's continue now and write another query. Now, this query, actually, I shouldn't have commented this out, is going to be the same as this, but we're going to perform some more steps in the aggregation. So let's put this down here. And rather than authors and books, we are going to get authors and a count of how many books it is that they wrote. So we're going to say author book underscore count. So the first step in my aggregation here, and there's multiple ways to do this, this is just one method, is I want to join the two tables together. So for every author, I want to get a list or an array containing all of the books that they wrote. That's great. That's the first operation that we perform. Now let's just make this look a little bit cleaner so it's a bit easier to write in. Okay, so this needs to get indented. And now we can put our next aggregation operation here. Okay, so this is the first operation that we perform. The next operation that we perform is going to be add and then fields like that. And I think this is intuitive as to what this is going to do, but it's going to add a new field. And the new field that I want to add to all of my results here, so all of the documents from this, is going to be total underscore books. And I'm simply going to say here that this is going to be the operation of $size. And then I'm going to reference, and this is going to be books like that. And I need to make sure I have my $sign here. So I'm adding fields. I could add multiple fields. In this case, I'm just adding one. The field is total books. And the value of this field is going to be the size of whatever the value of books is for each author that we're adding the field for. That's how that works. That's how you add fields. Now, after we add fields, though, I want to perform a projection so I only get specific fields in my return values because I don't need everything. So for here, I'm going to do an operation. This operation is going to be project. So in the aggregation pipeline, this is how you pick specific fields that you want returned. And then I'm going to specify all of the fields that I want for my author. So the field I want is first name. I want the last name as well. So this will be a 1. I want to get my total books field, which I just created in the last step. So I'm going to say total books is equal to 1. And then I'll grab the underscore ID. And I'm just going to manually set this to be 0 so that we don't get the ID. Okay, now that we have that, we have an aggregation pipeline that does 3 operations. So we look up, we add a field, and then we project. And again, this will be performed on kind of the last result. So we have this result, this gets performed on that, and then this projection gets performed on all of this, or whatever was returned, I guess, from this step. Then what we can do is simply print this out. So I guess I can just copy this again. And rather than authors and books, this will be author. Is it authors? Yeah, authors book count. Okay, so let's run that. And let's see what we get here. And notice that we have our author, total books, author, total books, author, total books, and the final author and their final number of total books. Okay, awesome. So now that we have done that, let's go and do some more advanced queries. So we just got the authors and their number of books. The next thing that we can do is grab all of the authors and their books, but only for authors that are a certain age. So in this case, let's do it so that we're grabbing authors that are between the age of, say, 50 and 150 years old. You'll notice that if we go back to our authors here, we have some that were born quite a while ago, so they would be quite old, and we're not going to retrieve those. So again, what we want to do is grab the authors and all of their books, but only authors that are within a certain age range. This is actually much more difficult than it looks, but of course I will show you. So I'm just going to grab this query that we wrote already. I'm going to paste it here, uncomment it, and change it a little bit, but we will start with this lookup operation. So actually I lied. We're going to start from scratch here, and I'm just going to say books with old authors is equal to production dot. We're going to use book this time, and then not dot find, but of course dot aggregate. And inside of here, we're going to have a list of the operations. Now, the first thing I need to do is for every one of my books, I need to find their authors, and I need to determine the age of the authors, because what I want to do here is essentially filter and only return books that have an author that's within the age of 50 to 150 years old. So this is fairly complicated because if we go and we look at our authors here, we notice that we don't have an age field, we have a date of birth. So we actually need to perform a calculation to determine what the age is. We then need to know the age of all of our authors, and we need to only select books that have authors that are within that age range. So the first thing we need to do is join our books with the authors so that we have the author data. Then we need to essentially loop through the authors, set the age of those authors, and then we need to filter so we only have the correct books with authors that match the age range. Hopefully that makes a bit of sense, but let's go through this. So let's go with lookup as our operation because we're going to perform a join. And notice this time we're looking up from the author collection because we are querying from book. So we're going to say from and then author. I don't know why it keeps giving me validator, but that's fine. And then we'll go with our local field. And the local field is going to be the authors, okay? Because we're talking about the local field on the book, so we have authors. And then the foreign field will actually be the ID of the author, so underscore ID, kind of the opposite of what we had previously. And then as well, this time it's not going to be books, it's going to be authors because we're adding this to our books. Okay, so now we have our lookup operation done. The next thing that we need to do is set the ages of our authors. So I have this authors field now, and actually what I'm going to do is replace the values in this authors array, because we could have multiple authors, with the age of the authors. So this will look a little intimidating, but I will explain what we're doing. We're going to start with the operator set. Now this actually replaces the value of an existing field. So we're going to change, in this case, the authors field. And the issue here with authors, or I guess a fact about authors, is that this is an array. So it's not as simple as me just grabbing the date, time that the author was born and doing the math with that. I need to do this for every value in this array. So this is where we're going to use the map operator. And we're going to map essentially some operation to every element inside of this array. So I'm going to say map, and I need to pick the input for the map. So for the input, we're going to use, and this is going to be $authors. We're referencing the field authors. Now I'm going to have in here, and what in is going to specify is all of the fields that I want to have in the array, and it will fill those in for every element for my author. So I know this is a little bit confusing, but you need to specify inside of in what you want to have in the array for each author. So I'm going to put an age, a first name, and a last name because those are the three values that I want. So just follow along here. We're going to start with age. Now to calculate the age, we need to use another operator. And this operator is going to be a date difference operator. So it's going to be date diff like that. But of course with our $, because it's an operator. And for date diff, we need to pass a start date. And for the start date, we're going to do $. And we're going to say this dot date of underscore birth. Now this is referencing the current element, and that's going to be the current element that we're looping through while we're performing this map operation. So you kind of have to visualize this in your head. As soon as we see map, that means we're iterating over every element inside of this array. The input array is, well, this, because that's what the map operation is doing. And then in is saying, okay, well, this is what we want to have in the array for each element. So I want to have my age. My age is equal to the date difference. I need to pass my start date, which is going to be whatever the date of birth is of the current author that I'm on right now. And then, again, I keep opening this, don't mean to do that. We're going to pass the end date, and the end date is just going to be the $, now. This just references the current date, kind of a nice, easy variable to use. And we want to have a unit here for the calculation, and the unit will just be year. That's the level of precision that I want, right? I just need to know how old they are, so I'm going to get year, and that's calculating the difference between the start date and the end date, just looking at the year. If we want to be more precise, we could go with month, day, etc., but I don't care. For now, we'll just go with year. That should give us the approximate age, and then we add that as the age field. Okay, so after age, though, we need to have our first underscore name, and the first name here is just going to be this dot, and then first underscore name, and then we need the same thing for the last name. So we'll say last name like that, and then of course that's going to be equal to last name. And if you wanted more fields, then you could access them with this, or you could do the calculation like I did inside of here. Okay, so that's it for this operation. Again, I know that looks fairly complicated, it is, but I wanted to show you some more advanced stuff, so I figured I'd throw it in. Now that we've done that, we should have the age for every single one of our authors. The next thing that we want to do is filter it so that we only get books that are written by authors within a certain age. So to do this, we use match. And essentially what match will do is it will have some query. And if this query is true for an element, it will keep it. So it'll run all of our documents kind of through the condition that we're about to put here. If the document is true for whatever we put here, it keeps it. If it's false, it doesn't keep it, just like when we write a query when we're finding documents. Okay, so I have match here. And then inside of here, we're going to put and, because there's two things that we want to check. Inside of the list here, the first thing that we want to do is we want to say authors. And then since this is going to contain multiple things inside of it, I'm going to say .h. Now, by default, since this is an array, and I'm accessing a value from an embedded document inside of this array, it will loop through and look at all of them. So I'm going to say authors.age. Again, that's referencing the age attribute of each of the authors or any of the authors that we have inside of that array. And I want to verify that this is going to be, if we go like this, greater than or equal to, and then I'll just hard code in 50. So the minimum age is 50. And then the next one that we want to have here again is authors.age, but this will be less than or equal to 150. So if you're greater than or equal to 50, less than or equal to 150, you are all good. And the last thing we will do here, just to throw in a nice touch, is we'll perform a sort. So I'll say the last operation I want to do is sort, and I want to sort by what fields? Well, I just want to sort by the age. When I do 1, that stands for ascending, so I'm going to sort in ascending order. Okay. Now that we have that, let's print this out. So printer.pprint the list of books with old authors. I believe that's what I called it. I'll zoom out so you guys can read all of this at once if you want, if you're going to pause the video and have a look at it. Do that if you'd like. Let's zoom back in and let's run this code and see what our result is. Okay, so when I run here, we do get everything that I expected. We get our authors, or we get our books written by authors that have, the specified age. So first book, 1984, age of 119 for George Orwell. And then lastly here, we have our age of 126, and this is The Great Gatsby. And the other books that were written by younger or older authors are not returned because, well, they weren't specified, right? And you can see that we get the age field for each author as I requested, or as I wrote in the aggregation operation. All right, so that has been it for the advanced query section of this video. Hopefully that gave you an idea of what's possible in MongoDB, showed you some of the different operators, gave you a decent example to run through here. Obviously, you're not going to have this memorized. There's a lot of stuff you need to look up from the documentation, but I wanted to give you kind of a good in-depth example and some different examples so you could see how you perform some common operations here and do some more advanced stuff. Now, what I want to end you with here is kind of a quick demo of this awesome library / module that MongoDB has made called PyArrow, or PyMongo Arrow. Now, what this allows you to do is essentially take MongoDB data and read this in as either a data frame, so a pandas data frame, a NumPy array. You can also read this in as an arrow table or an arrow object if you're familiar with what that is. So this is super useful for different data scientists, specifically machine learning people, or really just anyone using Python that wants these specific formats, because a lot of times you want to take data and read it in a specific format, right? You want a NumPy array, you want a pandas data frame, whatever. So this module you do need to install. Now, the command to install it is the following. It's going to be pip install, and then you need to install all of these dependencies. Some may already be installed, but I just want to run through them to make sure you don't miss any. So you're going to install Jupyter. You're going to install PyMongo Arrow like that. Inside of quotations here, I'm going to have PyMongo and then SRV, although you should have installed that in the previous video. And then we want pandas as well if we're going to be using pandas. Now, I guess we might as well do NumPy while we're at it, just to use NumPy. So run this command, should install everything you need. I already ran it, so I'm not going to go through it. Again, if this command does not work, you can try doing a pip3. If that doesn't work, you can do python-m pip install, or you can do python3-m pip install, and one of those should work for you. So I'm going to assume that that has worked and that you've installed that module, and now we can start working with it. So I'm going to say import, and this is going to be PyArrow like this. While we're here, let's do our other imports. So I'm going to say from PyArrow, and this is actually going to be PyMongo Arrow, PyMongo Arrow.api. I want to import a schema. I'm going to say from Py, if we could spell that correctly, PyMongo Arrow dot, and then monkey. We're going to import patch_all. And then I'm going to say import PyMongo arrow as PMA. Okay, so those are the 4 imports that I need for right now. Again, I'm not going to give you a full tutorial here. I'll leave the documentation in the description so you can have a look. But the first thing we're going to do is we're going to call patch_all. Okay, so patch_all like that, if I could type that correctly. And then we're going to specify our schema. So quickly though, let me just describe what this actually does. So patch all essentially makes it so whenever we deal with a collection object here in MongoDB, is that it has access to all of the API features we need for PyMongo arrow to read this in as a specific object, like a data frame, NumPy array, etc. So don't worry too much about it, but we just run patch all to make sure you don't get any errors here. And then, as I was saying, we need to specify a schema. So what we do is we specify a schema. We then can load our data using this schema, and that's what allows us to load it in as a pandas data frame, as a NumPy array, whatever. Because it can be very difficult if you take data directly from MongoDB and try to read it in as one of these formats. You usually have to write some custom Python code, which can be time-consuming and not necessarily intuitive to write. So this is a really quick shortcut, very easy to use. So for now, I'm going to say author is equal to, and this is going to be schema. Again, we imported that up here. And I need to specify as kind of a JSON or Python dictionary here, the values that I want and their corresponding types. So I'm going to say ID, and this is going to be object ID, but I need to import that from BSON. So I'm going to say from BSON import object ID. Okay, continuing here, I'm going to say my first underscore name, and this is going to be pyarrow.string. Now, you don't need to install that. It should just be installed for you by default. PyArrow is a module in Python that defines some specific types for you, a few other things as well. And this allows you to grab kind of the string type, right, from PyArrow. So pyarrow.string, you're then going to say last name, and this will be pyarrow.string as well. We then want to get the date of birth. So I'm going to say date of birth like that. And the type for this, I'm going to say is DT, so date time. Remember, I imported that all the way up here. So I have from date time, import date time as DT. Okay, so that's my schema for now. If you have some more advanced types, you will have to look those up from the documentation. For now, though, let me show you how easy it is to read in our data as a data frame from our database. Also, all my imports, sorry, they would have just gone to the top because I saved. My auto formatter does that. For now, though, let's say our data frame, so a pandas data frame, is equal to, and then this will be production dot, and we'll go with author, and we'll just say dot find pandas all like that. And then we can pass a query just like we would when we're finding data normally. And I'm just going to leave it empty so we get all of them. And I'm going to say schema is equal to author. Then I can do something like print df dot head, and this will give me a pandas data frame that contains all of my items, from the author collection based on this schema. Now, any fields that I have not specified here automatically will just not be included. We'll just leave them out. And if I've specified a field here that's not in any of my author documents, it will just have a default value of none or null. So let's run this though and see what we get. And if we get our pandas data frame, and it says it's not recognized. Sorry, let me run this again. And notice here that we get our data frame. Now, it's a little bit messed up just because we're reading some stuff in as binary. The ID specifically is kind of a binary object, but you get the point. This is our pandas data frame. We can treat this as a pandas object, and I guess it was running my previous query as well, so that's why we're getting that information. Let's just comment this out for now and continue and look at the other ways that we can read this in. So rather than just a data frame, we can read this in as an arrow table. So I'm going to say arrow table is equal to, and then this is going to again be production.author dot, and then find underscore arrow underscore all. And we'll say schema is equal to author. And then I can print my arrow table. So let's run that. And when I have a look at my arrow table here, you see I get the arrow table. If you're familiar with PyArrow, then you know what this means. Otherwise, I guess it's not of concern to you. Continuing, we have our NumPy array. So I'm going to say nd arrays like that is equal to, and this is going to be production.author.find underscore NumPy underscore all, pass our query, pass our schema, and then we can print the nd arrays like that, and we will get our NumPy array. So let's clear, let us run. And you notice here that we get our NumPy arrays. Again, this is kind of a binary object. You would need to deal with that. Won't show you that right now, but you can see we get all of the NumPy arrays that we requested. Alright, so that's been a short demo of the PyMongo Arrow library slash module. Hopefully you guys found this helpful and you can see yourself using maybe some of these features, specifically if you're going to be reading in or trying to convert MongoDB data to a data frame, arrow table, or NumPy arrays. With that said, I will wrap up the video here. Another massive thank you to MongoDB for sponsoring this. Make sure you guys get your free credit from the link in the description using code MKT-TIM. With that said, again, hope you enjoyed. If you did, leave a like, subscribe to the channel, and I will see you in another one.